Professor Bumbleweed here. Today's drama. The CPU, a tiny square that somehow bosses your entire device around. This quick tour explains what's inside, with enough clarity to learn something and enough attitude to stay awake. This chip looks calm, yet it runs a whole empire. Signals race in from memory and devices, hit the CPU package, then split into specialized blocks. Caches for nearby data, cores for work, control for bossy decisions. Corporate, but faster. Clock pulses keep the CPU synchronized. One instruction moves through a loop. Fetch, decode, execute. The clock doesn't think. It just pushes state changes in circuits. Somehow, that relentless loop turns into apps, games, and your endless tabs. Registers sit inside the CPU core and store values in the fastest place possible. The control logic picks which registers to read, pushes those bits into hardware, then writes results back. It's like juggling, except the balls are electricity. ALU stands for Arithmetic Logic Unit, aka the part that actually does the math. It takes values from registers, performs one chosen operation, and outputs results plus condition info for decisions. The control unit picks the route, bossy but effective. Memory has layers because physics ruins everything. Closest is cache, tiny but fast. Farther is RAM, huge but slower. The CPU checks nearby caches first, then reaches outward only when it has to. That chasing time dominates performance. Caches grab data in chunks called cache lines, not one lonely byte. That works because code often uses nearby addresses and repeats work on the same data. This habit is locality. When locality exists, the CPU looks brilliant. When it doesn't, enjoy waiting. A pipeline splits the instruction cycle into stages, so the CPU overlaps work. Instead of one instruction hogging the whole core, many instructions share different stages simultaneously. When everything flows, one completes almost every tick. When stalls happen, the line coughs. Branches ruin pipelines because the next instruction depends on a decision. CPUs guess with branch prediction, then pay a penalty on a bad guess. To stay busy, many cores execute out of order. Do ready work first, then retire results in order. Cheating, but legal. More cores mean more separate work happens at once. Some CPUs also run 2 threads per core, using simultaneous multi-threading. 2 instruction streams share the same execution hardware. When one thread stalls, the other uses spare slots. It's like carpooling for electrons. A CPU also manages the chaos around it. Interrupts pause normal execution, so devices get serviced promptly. Virtual memory uses an MMU, page tables, and a TLB cache to translate addresses and protect processes. So yes, the CPU babysits your programs too. If this CPU tour actually made sense, hit like. That tiny click tells us which topics land best, so more of the good stuff gets made and less time goes into questionable experiments. Thanks for watching and staying curious. Got a topic request? Drop it in the comments. Without ideas, I just stand here dramatically silent while the animators stare at an empty timeline, questioning every decision. Give us something fun to build next. See you around, humans!